continue. Okay. So now it's the fourth team. Yes. Okay. Now Rachel, please.
Okay. So I do think that all the data will be stored in the cloud, and I think on the previous question we made this point, which also applies to this question. The clouds have this property of elasticity, which also applies to storage. In this case, if you have a storage device, then in order to store more data when that storage device is full, you have to buy another one. But you might not use that second storage device completely until a certain point. Whereas in the cloud, you only pay for exactly what you use. And whenever you need more, it adapts to your needs. So that is very important for storage devices when you need to store more data. Also, cloud provides high availability of data, which means that wherever you are, you can access your data, and also they implement redundancy, which makes a copy of the data, if it's not available, then you have a second copy of several copies in order to make that data always available to you. Also, on the previous point, we talked about security, and Sama was talking about Doug's paper, the intrusion detection system, in order to figure out whether there's something wrong going on in the virtual machine by the hypervisor. But also, we mentioned in class about encryption, and there, I think the professor was the one that mentioned that in the future, or I don't know if in the present, CPUs will be able to work with encrypted data and produce encrypted data. So even if data is being sniffed out of a virtual machine, the person that got the data wouldn't be able to make any sense of it, because only the user knows what that data means, because it's encrypted. Okay, that's the end of my point.
Okay, who's the second?
Yes, me. So then, yes, and data will be stored in the cloud in the future. And I mean, it definitely makes more sense if you have all this data that you want to store it in. You definitely don't want to buy a device, so if you can purchase storage as a utility and then pay it as your monthly rent, and versus, I mean, how much would it cost? Like 5 cents per gigabyte or something like that. And that makes a lot more sense than purchasing other devices that eventually, after a couple of months of doing stuff, working with the data locally, they will break, and then you have to purchase another SSD for $500 or $1,000 or whatever it costs. And definitely makes a lot more sense. I mean, there's not a high latency that will be reduced in the future as we get more bandwidth and network connectivity. So that's not a problem. And we have data centers that can, I mean, I don't believe in the whole story about Watson and IBM having 5 computers in the world, but you can have local data centers in, like, per county or even locally. So you do have some spatial locality that you can take advantage of, and you know, there will be higher bandwidth, higher network connectivity. I don't have much to say about data locking or privacy. That's an important issue, and I mean, the data will be kept private if we can just encrypt everything and do computation with encrypted data.
Okay. Okay, so just to remind you, okay, although we're projecting the against team's slides, but you don't have to answer your questions, based on what they put there, okay? When you give the first 2 minutes to answer your question, you can answer in whatever you want. And but when you ask the follow-up and answer the follow-up question, that's when you can use the other team's argument to make your own argument. Okay. So now, so the for team, you can ask the against team follow-up questions. Let them start first. Yeah, because you answered first. Okay. Do you have a question?
Yes.
Of course. All right, go ahead.
So let me ask you a question. Present you with this theoretical situation. Either.
Then give it back to me.
Let's say you own a hard drive, and you've managed to fill up this hard drive with your documents and pictures, and everything is legal material, of course. This device is full. What do you have to do if you still have more data that you want to store?
That's the question?
That's my question. Well, obviously there'll be a follow-up.
But I have an answer for that.
What is that?
That you buy another hard
You
disk.
have to buy another hard disk.
Yeah.
So there's an additional cost there.
Yeah,
Additional investment.
yeah. But I think I know where you're coming from. The problem that I'm looking at is the rate at which my volume of information increases. So if the rate at which the volume of my information increases is very, very low. I invest definitely not $1,000 in hard disks. I know where you're getting those prices from, but hard disks is very, very cheap at the moment. So just buy a second hard disk,
Okay.
and that initial cost is going to be there for years, because since the rate at which my information growth is very low, then that money is going to be very small. However, if I would be investing in the cloud, I would have to pay monthly, whether I use that information or not, for how long I wanted to keep it there, which may be on the long term, a higher cost than buying a hard disk. In terms of if you want to talk about high availability, all I have to do is buy a couple of hard disks and create a RAID.
We're not talking about high availability today. I'll stick to the point. We're not changing the subject, because I'm not going to concede that point. So your argument, so what you say is that if your data is growing at a very slow rate, that investment will last you because it'll take you longer to fill that device. So by that same logic, 90% of that device is sitting empty until you've managed to fill it up.
Okay.
Whereas with cloud storage, you only pay for the storage that you're using. So there's obviously a trade-off there. You're
Absolutely.
claiming that there's one initial investment,
Yeah, but your point is about
Very
cost
infrequently.
effectiveness, right?
and I'm saying that your solution is very cost ineffective.
No, I don't think so.
Because your initial investment, which may not be very often, but initially goes unused.
Yeah,
Okay.
You're not benefiting
Okay,
from
give
it.
him a chance to answer. Okay.
when you divide that into the amount of months that I use that storage device, and I'm sure that the cost per month is going to be much lower.
You're sure? Do
Absolutely.
you have some data to reflect this?
Yes.
Insurance?
Yes, because the
Because I don't see where you, I don't see where you
Okay, let him finish. Let him
No,
finish.
I do have some data. How much each gigabyte costs in hard disk right now? It's how much is like less than $1, I think.
Yeah.
How much do you pay per month for storage in the cloud? Not to mention that you also have to have internet connectivity.
Yes.
Assuming that the data you're accessing with high frequency, you're going to have high internet connectivity, otherwise it's going to take forever. So I think my solution for small-scale problems is much more cost-effective than yours.
Okay, that's it. Do you have a second question?
Yes, go ahead.
Yes, we have a question. It's not here, but I just thought of it now.
Go ahead.
One other thing that is good about having your data in the cloud is that it keeps everything, all of your devices synced with that data. How else can you achieve that without cloud storage? In your iPad, your phone, your computer, multiple devices.
I actually don't see service such as Dropbox as a cloud. It acts much like the FTP server on our side, right?
But it is cloud hosted.
Anyway,
It is cloud hosted.
Huh?
It's hosted on cloud.
It's
Utilizes
it's,
cloud
it's
technology.
not a cloud.
That's okay. He does not think that's cloud. So explain.
EC2? It's on EC2.
Why is it not a cloud? I mean, it's those U drive. It's not a cloud. You can partition the cloud into multiple clusters and assign each group of people to use a single cluster, which is not a cloud. You can gain the same objective as synchronizing all your data on all of your devices as long as there is API.
We obviously have a problem because we have different definitions of what we define the cloud to be. I was taught that the cloud is
That's
whenever it's
perfectly
not-
fine.
not part of it.
That's perfectly fine. Okay. Are you done, Ichi?
Yeah.
Okay. So the judges, do you have any questions? Okay.
I
Okay.
was going to make a comment
Yes.
about this particular topic, in that it's just an opinion for you to consider. But I tend to think that eventually, even if there are a lot of points against storing certain types of data in the cloud, that eventually, as things become more globalized, like let's say that you're on a vacation to another country and you get hurt and you go to the hospital and they don't have your medical records, so they don't know like what they can and can't do to you, or how it might affect you. You don't think it would be better that to have some kind of a medical cloud, for example, where they can just pull your medical data from right there for when you need the help? Or this could be applied for any situation, education, storing textbooks and lectures on an education cloud. There are tons of ways to use this to increase efficiency across the board. I think eventually, it might not be in the next 10 years, next 50 years, we might not be alive when it happens, but eventually, everything will be able to be accessed remotely.
Okay. See, we have a believer. Okay. So okay, now, okay. Now the judges will take a moment to grade, okay, but just remind you, when grade, try to be impartial, don't grade based on what you believe, okay? Grade based on why the arguments make sense or not. You don't have to...
But obviously your arguments make more sense because...
Okay. Okay. So, and for the against team, you don't have to be concerned. Maybe that's the impartiality, because in the end, migrating counts more weight. Okay. Yes.
I want to make a question to maybe you or everybody about the definition that we were talking about.
Yes.
The question that he did is precisely in this question, like saying like put the data on the cloud. What exactly means? Because we know that the cloud is like Amazon. It's a company that has virtual machines or has machines or whatever, and has a hard disk. And what it really happens is you from university connect to Amazon to that disk that they are selling you, and you transfer your data, right? As the cloud. Basically. What happens if I have my machine here in FIU, I go to Bolivia and I connect from Bolivia to here and I copy my document? That's considered.
You're utilizing the same exact technology in the same exact manner. What's the difference between U-Drive and Dropbox in terms of functionality? One is hosted on Amazon's cloud, and the other is hosted on our servers here. They all implement data reliability, redundancy, elasticity. One's free and one's not? Well, what's the difference?
You asking me?
Everybody. If we're going to use, Dropboxes or U-Drive,
I think we should stick to the definition that internal data centers, such as the one that FIU uses, should be considered something different from a cloud.
It's a private cloud.
I think it's and I'm using this based on one of the papers that we read, which they differentiate between these two: the public cloud and the private.
The private cloud. So we're talking about cloud computing.
Cloud computing.
We're talking about
outsourcing.
He just mentioned outsourcing.
Outsourcing.
That's one of the issues about public computing that where we're at.
Okay. So the different levels of cloud. Okay. Outsourcing is a good word. Okay. So cloud is a service provider. Provide some type of service. Okay. And there's a business model behind it. Okay. So when you say FIU has a private cloud, we may have it. I'm not sure. FIU has the Gmail, right? Or the U-Drive, which I haven't heard of until now. So that is a private cloud, but it's private means that it has a limited scope. Okay, so it has a limitation, has its advantage. Okay, and the public cloud has a broader scope. Okay.
So are we arguing for public clouds, or are we arguing for
both
technology?
I don't differentiate between private and public in my questions. Okay, but when you're making arguments, you can point out what are the limitations of private cloud, what are the limitations of public cloud. Okay, but my question is generally speaking for all types of cloud. Okay, well, I'll be done with grading. Okay, so, can you help me flip the slide? Oh, you have asked guys?
No.
Oh, I'm sorry. Okay, please, please go ahead. Please go ahead. Yeah.
Say, national security outweighs personal privacy, right? So in the example of CIA director scandal, they were communicating between
So what's the question about?
Do you agree to a law that outweighs your personal privacy?
Privacy. Okay.
So what you're asking is the cloud will give you an agreement that says everything that you store here would be made public eventually, or at some point?
No, private, not too big and private that nobody else can see it.
Other people.
Is there time to ask some questions?
Yeah, that's all.
Would I agree with that?
It's a law, he says, not a policy,
Yeah.
a law. But the Congress want to
Well,
pass a
it
law.
doesn't matter if I agree or not, it's a law.
Will you endorse that? Will you agree with that? You can agree or disagree, but you must obey it.
Yeah,
Do you agree?
no, of course not.
So that's the answer I need.
Then you
I
don't.
don't see how that concedes your point, but it's okay.
Then you don't think. Okay. Then you don't think that the cloud will be able to provide the same level of privacy that you would have, right?
If that law exists, no, they can't.
But they-
Because it's a law. They
but-
can't go
okay.
against the law. I mean, as a company, they have to abide by the law.
This question was is what you agree or disagree. No, if you are putting the law. You
Okay, I
disagree with
don't
the-
agree with making my data public or made read by other people. I don't agree with that.
So you will not
Okay.
store it.
If that law passed, if that theoretical law that doesn't exist passed, then yes, I would not use a problem.
But that doesn't make any sense. It doesn't make any sense because if the law is making your private data public,
Of course.
obviously nobody.
Listen.
goes to the cloud.
Listen. Go ahead.
I'm just saying that if a law will make your private data public, it doesn't matter if it's in your computer in your house.
Doesn't matter.
Yeah.
There's an easy way to.
Nobody's getting close to my habits.
So now we're talking about
You're
breaking
gonna
the law.
kill the
They would
police.
need a warrant if they wanted your hardware.
But in the same way that they
But
will pass
if-
a law to make a your.
The
Okay.
FBI can request data from Facebook without your permission if they want it.
Well, that's
So
why
they
we're
can't-
saying
Okay.
Well,
They
I'm
can
just
also
saying
go
that.
to your house and go into your
Yes.
computer.
Okay. I think that's very good discussion because now we're touching a completely different issue, the legal issues here, right? And that's very good discussion. Okay, so maybe that law doesn't make sense, right? So do you have any other follow-up question?
We have no questions on the.
Do you want to ask this?
Okay, go back to previous slide.
No.
This one. Okay.
Don't you have it printed out right there?
No.
Go ahead.
No, the last one. The last
Next
few.
The last
The last
one?
one. The last few.
Keep going.
One of these?
Yeah.
Oh, no.
Okay. You
I did that last time.
no, you ask this question later. Do you have any follow-up question now?
Follow-up question.
You should.
I'm using every advantage of my ability.
Okay, so you don't have a question. I take that. You don't have a question. Okay, for the sake of time, let's move on. Okay. So Dukawa, please go back to the third question. The next one.
Yeah.
Next one. Okay, that's it. Okay. So this question is that will cloud computing eliminate the need of personal computer? Okay. So now we start with the 14. What?
They don't need to do two questions.
They already did it. They already finished it. Okay.
So we try. Yeah.
So okay, let's take a moment. Okay, so in second question, Rachel and Sama answered for the 14, and Leo Ichi answered for the against him. Okay, please grade that is four questions.
Oh, sorry.
Unless you.
Yes.
Okay. We ready?
Okay.
First of all, I'd like to start by saying that I resent this question. That I think that it was specifically worded to work against our argument. So I would argue that personal computers have not broken the belief that the world needs only 5 computers to make computing pervasive. Personal computers, if anything, have proved that we can do it with more than 5, but have not proven that we only need 5. The initial assumption was, in the future, we will only be fine. And I believe that that's still true. Warehouse computing has proven, if we can assume that a warehouse is a single computer, then warehouse computing has proven that a large number of people can be serviced with the same functionality as having a personal computer in your home over the network we call cloud computing. Right here. I can do everything that I do on my home computer with a smartphone. I can do everything that I do on my home computer with a tablet. I can play high-definition video games without a graphics card by streaming HD video through a functionality called cloud gaming. Everything that you need to do on a personal computer can be done cheaper and more cost-effective via the cloud. And that's really all there is to it.
Okay.
Why would you spend the initial investment to have a computer in your home that you're responsible for maintaining, upgrading, powering, when you can pay a small fee to have a much cheaper and more power-efficient machine at your house that all it does is connect to a remote cloud, which does all the computing and storage for you remotely. I just don't see the argument on that.
Okay. So who want to give a second
It has to be
answer?
It has to be Rachel.
Okay, Rachel.
Doug pretty much talked about everything that I really need to say, but I wanted to add one more thing. You guys talked about something there that reminded me of the things that we discussed while we were preparing for the debate, and we were talking about less developed countries, and specifically with respect to education. And one of the things that a big warehouse computer would benefit less developed countries that don't have private clouds or have any type of warehouse computing on their own countries is students or kids there could have, instead of computers on their own schools, they could have tablets or other mobile devices that don't have actually computing power and like as much computing power as a real personal computer, but they could use the cloud in order to learn other things. And Todd was telling me about a guy that, because they had Google, they built turbine engine to a windmill, yes, to power his school. So actually having a warehouse computer for the less developed countries in order to learn, I think it would be a great idea. So I do think that
Okay.
computers would be.
Okay, the against team.
Do we answer the question, or?
You answer the question.
Haven't.
Yeah.
Answer that question.
Oh, we first answered that question.
Right.
Yes.
Okay, so obviously I disagree with that cloud computing will not eliminate. I agree. I disagree that cloud computing will. Cloud computing will not eliminate the need for personal computers because the main reason that I think it's availability. You guys mentioned that cloud computing has all these guarantees of high availability and replication mechanisms and all this. But the fact is that there's two aspects. There's two things that need to work in order for you to access the cloud. First of all, you have to have a cloud provider that has the infrastructure to provide this constantly. We know that it's impossible for cloud computing to always have it available. We've seen this in the past. An example is Amazon's storage. I forgot the specific name, but for example, it's happened recently.
S3?
No, I think it was the
Dynamo?
EV2.
I mean,
So what EV2? It's a
yeah,
storage.
okay.
So what happened is that this service went down, and what happens? You have websites like Reddit, Netflix, and other popular services that were unavailable for a certain period of time. So clearly, if there is no 100% guarantee that services will be available from cloud computing. And this would even be more pervasive if we had 5 data centers or 5 huge cloud computing centers. In addition, there's a side of the client. You need to have constant internet access if you want to access your data. And everybody knows that this is not always possible. Whether it will be caused by a natural disaster like Sandy, where you have no internet connection, or you go into a building that the material doesn't allow you for the signal to get to where you are, or even if there's no coverage because it's not economical. That means that if the internet is not available, then you have no access to your data or services. And that makes it impossible or even totally infeasible for this to be true in the future or now.
Okay, who wants to give the second answer?
It has to be Leo.
Because we could.
This is the last question.
Having the.
Okay, so, well, to answer that, I don't think it makes a lot of sense because basically what you guys, what is being proposed is a centralized model. I mean, all the computing power is in one place, which it doesn't really matter how big it is. I think it's common knowledge that when you have centralized model, when the workload gets big enough, at some point it's not going to be enough. So a centralized model, it makes more sense, in which the computer power is distributed all over the world, supposedly in a centralized place. Keep in mind that if you have a model in which we have 5 clouds, it's going to have in specific locations, which could be easily targeted by terrorist attacks, for instance, or natural disaster, as you mentioned. On top of that, I don't think we still have the infrastructure in place, depending about the networking technology, to make it cost-effective to access that. As you mentioned, there's areas in which there's just not cost-effective to have internet connection. And we have many of those here in the United States, many in third world countries. Like if you live in West Virginia, or places that it's not expected to have the run cable from Comcast. What else would I say? That model is also not good for a specific type of computing. For instance, in a model like that, you can have general purpose computers that are cost-effective building. But if you have specific computing that you have to do, which requires specific hardware, then cloud is not going to address that because cloud is meant to address the needs of everybody, not specific needs. For instance, if you need to do computing that is best performing GPUs as opposed to general purpose CPUs, cloud most likely is not going to address that because cloud is for general purpose. So that model is going to basically avoid a wide variety. It's not going to allow for a wide range of type hardware, which is better to have, I think. And I think that's all I have.
Okay. So now the against team can ask the 14 follow-up questions.
14 has the against.
Yeah, 14 has the answer. Yeah.
Okay, I have a clarification. In this case, we're assuming that users access the cloud through thin client that have neither storage or computing power, right?
Right. It's not what is a PC? Okay, it's not a PC anymore. Okay.
Right. So no storage or computing power.
That is.
I'm willing to concede that.
Yeah, I don't want just not a PC. Okay, that's why I want to go. Okay. Yeah, something that you cannot. Because even a mobile device has storage and CPU. Okay.
Yes, but it doesn't have the power and storage scale that a PC has.
Correct.
It has an Atom versus i7. You see the difference?
Wait, because you're assuming that all PCs have an i7.
No, they don't. Not all of them. Not all of them.
You have when you say PC, you have to consider what is a modern PC. Okay, not the PC in the 50s or 60s. Okay. Okay, now you can ask question. You can ask question now. You have a question for the 14? Yes. You don't have question?
The follow-up question is.
Follow-up question. Follow-up question. Okay. Based on the answers.
Do you think that the network technology at the moment will allow us to have a model like that? Don't you think that, what I mean by this is that the model that we have is that we have a bunch of protocols and every time you send a package, that information is packed into multiple layers and actual, the percentage of the boundary that you use with actual information as opposed to all the crap that you have to support different protocols. So it's very inefficient, the network that we have today. Do you think that technology will be enough to have a model like that? Do you think it's cost effective to build a model having the technology that we have in place, or what are the changes that we have to make in infrastructure?